Hi, my name is Olivia Heidi, and I did this project with Alessandria Perez, who's a graduate student of Missouri, Alexandria Herrera Martinez, and Juan Daza from Sam Houston State University, and Richard Thomas from the University of Puerto Rico. The title of my research is Smaller, 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 and it's about some of the smallest amniotes in the world, geckos. So this project is derived from fieldwork 13 years ago when Juan Daza and Richard Thomas were exploring the species in Puerto Rico, and they discovered a population in the south that included some of the smallest geckos on the island. So Sphaerodactylus nicolsi is known as the Puerto Rican crescent gecko. This is due to the crescent-shaped marking on the top of its head. Looking at these small animals, we wanted to compare and see if others on the island were sharing the same reduction in size. So this species has populations in the north and in the south, and it's actually now starting to be present in the west as well. So our aim with this research is to compare the north and the south populations and see how different they are. And additionally, we wanted to do a detailed comparison between this species and the smallest amniote in the world, which is another species of the same genus found in the Dominican Republic. So that species is Sphaerodactylus ariasi. So doing this research, we gathered x-rays from multiple specimens in a digital x-ray machine, and then we gathered measurements from those. So we measured skull length and SBL, which is the standard measure for length in lizards. And with these two measurements, we did a series of statistical analysis in which we performed a Wilcoxon sign rank test to examine the differences between the north and south populations. So in addition to that, we gathered CT scans from two specimens from one of the smallest animals in their sample from Puerto Rico, and we got a CT scan from one specimen of Sphaerodactylus ariasi. So looking at these, the results were pretty clear. Using both skull length and SBL, we discovered that the north populations are actually larger than the south populations. So that's actually a really interesting find, considering that these two populations of these two groups of animals have discontinuous distribution along the island. So there are some characteristics that are different in the island. The north of the island is more mesic, while the south of the island tends to be a bit more xeric. And looking at the results here for the north and the south SBL and skull length measurements, we now know that the north and south populations are actually different. And we do want to find some more specimens from the north. They are pretty difficult to find, which is why there are less specimens in our sample here in our research. But we are planning on going to the University of Puerto Rico, where there are more specimens and we can take more measurements. So now that we know that the population is so small, we wanted to see how similar these geckos are to the smallest species in the world that lived in the Dominican Republic. So for this, we used the CT scan data and we segmented every bone. So you can see here in our illustrations, some of the work we did with that. We did a rough comparative analysis. Although these geckos from Puerto Rico are tiny, we found out that they still are larger than the smallest amniote in the world. So we found that the skull of the specimen we scanned is 1.2 times the size of the smallest specimen of Sphaerodactylus ariasi. So this is actually very interesting because you can really tell how small these geckos are. We found some interesting osteological differences when looking at these as well. So for example, you can see here on the poster, we have these images to our right. Sphaerodactylus ariasi have a open proatic foramen. So if you look there, there's an opening from one of the cranial nerves in these geckos that is completely open, and this is probably due to a constraint of size. So the nerve is getting too big for the skull and it must remain open, whereas in Sphaerodactylus nicolsi, it still remains closed, just as it does in a majority of geckos. So this is a very interesting difference. Another characteristic we found that you can see here on my poster is the frontal parietal suture, which is the bone between the frontal here in blue and the parietal in darker blue. It is narrower in Spherodactylus nicolsi compared to the size in Spherodactylus ariasi. Also, the jugal bone, which is the bone that extends from the orbit here, is proportionally longer in Spherodactylus nicolsi. So there certainly is convergence attributed to size. So both skulls look pretty similar, but you have to consider that both species are basically pushing their limits to become very small. But it is interesting to know that all of the geckos of small size in the Caribbean, they always tend to occur in areas that are really xeric. So you have geckos in Guantanamo Bay, Cuba, that are a very small species, as well as a different species in the Virgin Islands that is very tiny. And now we see Spherodactylus nicolsi in the south of Puerto Rico and in the Dominican Republic. So revision for the future, definitely of microhabitat of other miniaturized geckos in comparison to cranial anatomy would be very interesting to determine if what we are seeing in this extreme size of the animal has evolved multiple times in the group. And I'm very proud to say that the research that we have done here has contributed to that. And I hope that we continue this research and grow it. And there's continued support in this field, in this inquiry. So thank you for watching my presentation. And I encourage you to please comment any questions that you have below. And thank you again.